morning. First of all, we need to ask you to change your groups. So, group 5, new members. Let me check. Group 5, 1, 2. Okay, maybe fine. Group 6 there, right? And group 4, you need to change. Some of you need to change. So maybe currently group 4, you 4. Maybe you go to group 3. Yeah, here. And group 2, some of you move to group 1. And 2 of you move to group 3, here. So keep in mind, since this week to week 9, we will have the current groups. Maybe later we have some students join you. So we will have the new way to have the groups for you. All right, so let me continue. We finished the discussion for chapter 2. And chapter 2, you have the circuit programming. And you can try it later. Meanwhile, you need to think about how to have your group members for the final project. And next week, I will ask you to have the further discussion in class. So you need to find your permanent group for the final project. Is it okay? It doesn't mean we have the groups right now, or maybe you think, okay, right now you want to have the group for the final project. That's fine. You just follow the syllabus to find enough members to form the groups. Possibly 7, maybe 6 to add, or maybe 7. All right, so you can try to find the group member to have the final project. And I will ask you to show running the program in chapter 2. So what's the outcome? And so that you can have the start for the circuit programming. So that's why you can find your member, at least some of your members can run the circuit programming. And possibly I made that you have some video provided by TA in the past. And so that you can have some reference how you run the program for chapter 2, circuit programming. Well, next week. And this Wednesday, we will already have the first quiz, right? So be prepared. And the scope ranging from chapter 1 to chapter 2. And maybe possible questions in class, and some possible problem for your self-exercise. All right, so these, I think, keep in mind this Wednesday, and also the possible group formation in the next week for the final project. Well, that's it before the discussion. I already have these. Well, right now, let me formally start the discussion for chapter 3, transport layer. We have an application layer in chapter 2. So we have transport layer for chapter 3. We expect you to have some transport layer service, and so that you know the principles. And what kind of principle we want to focus? Mainly focus on reliable data transfer. Before reliable data transfer, of course, we will already have the discussion about multiplexing and demultiplexing, because we have circuits. So still we have the issues of multiplexing and demultiplexing. And after that, we will have the focus of the chapter, reliable data transfer. And we will maybe take a long time to address reliable data transfer. And after that, we have flow control, congestion control. So of course, we expect you to have the two layers, UDP, TCP. And if we talk about reliable data transfer, in fact, we focus on TCP. Well, and after the congestion control, we already have the detailed version of TCP congestion control. So that says before that one, we have the general one, general congestion control. And this one is a specific one, congestion control for TCP. Well, so this chapter actually will emphasize reliable data transfer. Well, so here we have the roadmap to go through transport layer. Of course, we already have transport layer service quickly. Then we already have concepts of multiplexing and demultiplexing. And after that, we have the quick discussion about UDP. Well, so something like we review the transport layer service and protocols. So here we focus on transport layer. And transport layer, we have the end-to-end transport layer. Right? So we will have the logic communication from the host to the host. In chapter 1, we already know talking about the protocol stack, application layer for the end-to-end, transport layer same for the end-to-end. All right. So of course, we have the end-to-end communication connection. So we provide the logic communication between the application process running on different hosts. So I already know we can have client 1 and server or client. So we have the logic communication between application process running on different hosts. Well, we already have name of the data. We call segments if we talk about transport layer protocols. Well, if we have the segments, is it possible to get it back? Sure. We have the message first. Split into segments, then we will reassemble so that we still can have the original message. So these, I think, we don't know in chapter 1. And of course, we have the focus on TCP and UDP. In fact, we may have the other transport layer protocol. But in the internet, we focus on UDP and TCP. And later, we just want to let it feel if we have the transport layer. And furthermore, we want to have the next layer to have the following example, network layer. And right now, we just want to let you feel what's the possible service for the transport layer. And actually, the transport layer need to have the service provided by the network layer. So that's why right now, we let you have the possible service for the transport layer and network layer. And think about right now, we have the household analogy. We have 12 kids. And one family, we have N. And one family, we have Bill. So we have 12 kids in N's house and 12 in B's house. Right now, we want to have the analogy. So house, it's house. All right, so house 1 and house 2, all with the initial H. So we have a house 1 or house 1, house 2 or house 2. So currently, the analogy will be okay for you, right? And process, here we have the mapping to the kid. And furthermore, we have the application. Well, for the 12 kids pair, they want to have the communication. So they want to have the later. Therefore, we will have the later, and actually later in the envelope. So we have the application writing a later. All right, and then we will ask, for example, N want to write a later to Bill. And likewise, Bill possibly can return the mail to N. So we have the analogy. And so they will want to let you know, oh, currently we have a transport layer. And transport layer, actually, we have the process for each kid. So transport protocol, N and Bill need to do something. And for the transport layer, here we mentioned the fundamental service provided by the transport layer. So we want to max and actually demax, multiplexing and demultiplexing. So for the transport layer, at least we need to have the two functions, multiplexing and demultiplexing. And later we will already have the two functions or two service in the transport layer. As for the network layer, actually we need to rely on the postal service, and so that we allow the later to be sent to maybe the receiver. For example, Alice wants to write a later to Bill. So we need to rely on the postal service. And that postal service actually is the current network layer protocol. Well, so in fact, we want to have a story like this, writing letters, and so that we have the possible transport layer service. Here we know max and demax. And currently, maybe you don't know what that means, max and demax. For example, we have 12 kids in Alice's house. So maybe we have 12 letters possibly. It doesn't mean we always have 12 letters, but possibly we have 12 letters, and Alice can collect the letters and then send to the postal office, right? And so that the letter can be sent to a different house. And likewise for Bill, doing the same thing. So collect means we have multiplexing. And talking about the site for Bill, once we have a letter, someone like Bill, Bill wants to put the data properly to, for example, to kids 1 in BS house. So try to distribute the later properly to each kid in BS house, and then it is called the demultiplexing. So collect laters. Here we have the analogy of multiplexing. Once we have the laters, then you need to distribute the later to the individual kid, and then we have the demultiplexing. So at least we have a service in the transport layer, multiplexing, demultiplexing. Well, before we continue, maybe let me mention, we need to change the group member. So previously, for you, yeah, maybe you've ever joined group 6, right? But right now, maybe it's okay, I ask you to join group 3 there. Over there. To there. That's correct. All right, so let me continue. So we have multiplexing and demultiplexing. So right now, yes, we have transfer layer action, and oh, sorry. We need to send messages, but right now we have a segment. So we need to have a segment, and because we consider the current transfer layer, so we don't care about the lower layers. Of course, we already have an IP, the network layer, and here we focus on same. We focus on transfer layer. So we have this. I think it's okay for you if you check the protocol stack. And check, then we can have the messaging. So we have these. Well, let me show you again. So first of all, we can have multiplexing here. All right. But we emphasize the site when you receive the segment. And this one, we have extraction and demultiplexing. And later, we can show them explicitly. So we have multiplexing and demultiplexing. All right, so we have multiplexing and demultiplexing. Later, we will emphasize them again. And of course, we will check the multiplexing and demultiplexing for both TCP and UDP. And TCP in chapter 1, we don't know, we have the property of reliability. So we have the in-order delivery. And of course, we have the other service, including congestion control, flow control. And of course, we have a connection oriented. So we need to have the connection set up for TCP. But for UDP, it seems to be no service provided by UDP. Just send the segment, actually segment associated with TCP. For UDP, we will use a different term, datagram. So just send the datagram, and we don't have the reliability, so that an order delivery will be possible. And it seems to be just as the IP to send. So we have the best effort provided by IP only, and we won't have the other extension. So no other extension here. We have the term no frills extension. What it means? No frills extension. Frill, this one. All right, so you can check it quickly. So we don't have the other edit service. So we have the no frill extensions. All right, no frills extension of the best effort service provided by IP layer. This is the network layer. And of course, for both TCP and UDP, we cannot guarantee the delay. How to guarantee delay? It's hard. So TCP and UDP we won't provide the delay guarantees. And of course, we don't have the bandwidth guarantee as well. Well, so this is the current discussion up to now. We didn't have the multiplexing and the demultiplexing service in the transfer layer, but later we will have the detailed discussion. Before that one, here I ask you to have the attendance checking. You is the current group, all right? New group for you. Now, okay, so let me enforce it. So that is have 2 minutes because some of you perhaps join online. At this, let me make sure for students in the classroom, not finished. Okay, so at this, okay for students in the classroom. Also, the others, maybe allow them to have 30 seconds. And so they will reach 2 minutes. So let us continue. Multiplexing and demultiplexing. So why we need to have multiplexing and demultiplexing? Because we need to allow the process to have the proper identification. So here we have these. Talking about web, so we can have a server, of course we have a client, and like the current scenario. So for example, current client, we have Netflix. And actually Netflix is the multimedia on HTTP. But still we have the application, and of course we have the web, and we have the multimedia application on web. Same. If we want to return the web, so we can have this kind of possible transmission to this kind. And likewise to the other one. And of course, we may have the request from client 1 and client 2. So we will have these. Client 1 and client 2. And so that possibly we will have the process from client 1 and client 2. All right. But currently, just try to send to the server. So we have the question mark for you. Well, at least we already have the socket and process. And so we have the something like the symbol for socket and symbol for process. So currently we have some scenario like the previous one. We prefer something like those. So here we have a process. Well, so this is the multiplexing at the center. Multiplexing, we need to handle data from multiple sockets. So multiple. Put them together and send it to the corresponding receiver before they reach the destination. So here we have the multiplexing. And the multiplexing, maybe some, yeah, indeed, some socket coming from different hosts. Right now, go to the current host. So we need to have the multiplexing. Here, the multiplexing at the receiver. All right, we need to direct to the correct sockets. And we emphasize the multiplexing. And that, actually we may rely on multiplexing, but we emphasize the multiplexing. So here we want to ask you how the multiplexing works. It says we have an IP datagram, and of course we have an IP source IP address and destination IP address. And of course we have the port number, right? So we may have a source IP and source port, and the destination IP and destination port. But later we want to know if we want to identify. So how to identify? And of course we know that one. We have a source IP, destination IP, and currently we have the segment here. TCP or UDP segment format. We have a port number explicitly, right? Where we have IP? It seems to be IP missing. Why? Why IP missing? We don't know we have a source IP and destination IP. But why IP is missing in the segment format? In fact, IP should be the field in the network layer. So of course, we don't have an IP in the current field. But we still want to have an IP for the following identification. However, I just want to mention IP not explicitly shown in the current segment. No. But later, we still need to rely on IP. Well, if you check chapter 2, we have the UDP and how we have the demultiplexing, we need to check. This one possibly different from the possible version in chapter 2, but we have circuit programming, so we can create the circuit. And currently, we already have the pole number explicitly. In chapter 2, no, we don't mention the pole number for the client. But currently, we have the explicit pole number. So of course, we can have the client port. And of course, we want to specify the server pole number. So at this moment, we have the port associated with the current circuit. We emphasize the circuit. So we can create the datagram and we have the circuit. Of course, we have explicit specification for destination IP and destination port number when we have the program for UDP circuit programming, right? So we mentioned we have the destination IP and the destination port number. In chapter 2, we do something, actually, we do something like that in chapter 2 program. Well, when receiving when receiving host receive, so we have the receiving host. Receiving host receive the segment, then it will check destination port number and in fact, if we have the different port number, then okay, we have port number 1 and port number 2. Then we can direct segment to the proper one. So this is the current one. If we care about the multiplexing for UDP, even previously we have the web service, and the web service actually to the same one. So currently, we just pass on the IP and the port number for the receiving host. And we didn't know this simply. All right, so we pass on the port number. All right, pass on the port number to have the distribution. Well, so you see, IP plus UDP, actually currently we consider UDP, and with the same port number. All right, but think about this. We don't have the same source IP and source port number. but we will direct it to the same circuit. So indeed, currently, if we have the current way, we have a destination IP and the destination port number. Because we consider, for example, server. So of course, we have the same IP. And furthermore, if we receive the same port number, how to do? Currently, we will direct the datagram to the same circuit. So here, we already have the same circuit. So that's why the previous page we already have the question mark first. Because based on the current way to identify how to distribute the current circuit to the proper one, we pass on the port number. Even we don't have the same source IP and the source port. So here we have this way to follow the current discussion. Well, previously we have a question mark there. So it doesn't mean we have the same circuit. And right now, look at this. We have client 1. Right? We have a client 1. Of course, client 1, we create the port number 9157 and client 2 5775. And of course, we know it's the port number associated with client 1 and client 2. And of course, we have the source IP for each client. And send it to the destination. Here we have a server. And also, we consider UDP. So currently, we talk about UDP. Previously, we have, well, actually, it should be TCP, but we consider UDP here because we consider connectionless demultiplexing. Well, so currently, if we have a UDP, we will direct it to the same circuit. And so that we have the current process P1 for the server. Well, and if we want to return the same, we will have the return one. But right now, I ask you to check in detail, for example, this one. The current highlighted one, all right, we will have a source port. It should be 9157, and destination port we have 6428. Is it correct? The current highlighted one, source port, destination port. And how about the upper one? Correct. Source, destination. Right, you just reverse the direction. So we will have a destination port to the source port, right? And likewise for client 2. So of course you can have the pair, and of course follow the previous way to have the distribution. UDP, we just check destination IP and destination port. And right now, if we have sockets at the receiving host, so how to do? We just follow port number. Port number, same, so you direct to the same socket. So for UDP, we do something like that. So up now, it's the demultiplexing for UDP. Well, about the current discussion, is it clear? Should be, right? Of course, we already have a question mark there. So it doesn't mean we always follow that one. So that you have the question mark initially. But right now, for UDP, yes, we follow IP and the port number, so that if same IP, then same port, so we have the same circuit for the current discussion. Well, that's UDP. So UDP just care about destination IP and destination port. However, for UDP, previously we have web. And actually, web should be TCP. However, for web, for TCP, we don't do something like UDP. We care about the further way to distinguish the circuit. So we include source IP and source port. And currently, if we have the extra two fields, so we have the full tuple, source IP, source port, destination IP, and destination port. And so that, yes, we based on the full tuple. If one of them not the same as the others, then we don't have the same full tuple. And so that we will have the different circuit. So the multiplexing, we need to check all four fields. And one of them different, then we don't send it to the same circuit, right? So this is TCP. And so then for the server can support simultaneous TCP circuits because we don't have the same source IP or port number. Then we will have the different circuit. And so that we will have the different circuit to support simultaneous TCP connections. So here we emphasize this one because different client, of course, we don't have the same IP. So sure, we don't have the same circuit. And this is a scenario we reached previously for web server. So actually, web server running TCP. If we have TCP, then we can have the different circuit. For example, current 1, 2, and previously for UDP, we have the same circuit. But right now, no, because we consider the source IP and the source port. So from different hosts, of course, we don't have the same circuit. And how about if we have the next one coming from the same host, but different port number? Of course, we should have the different circuit too. So, for example, I use client 1, but currently we have client 2. Client 2, we have the actual process. So we get process 3 at client 2 to have the different circuit and different process at the server. It's process 5. So this one, we directly have the actual one. So for the current situation, it's web. For web, actually, no, we can support multiple clients. And here it's true. We can support multiple clients if we have TCP, because TCP current consider source IP and source port, so we can have the way to identify properly the circuit. Yes, we expect to have a different circuit, and we have the different process. Well, so this is the multiplexing for TCP, not UDP, because UDP just use destination IP, destination port number. Currently, it's TCP, so we should have full tuple containing source IP, source port, destination IP, destination port. So currently, if one of them different, then we should have the different circuit. And of course, different circuit here, we have the different process. Well, is it okay? And of course, you can check the corresponding IP port number, and so that you will have the full tuple. You see, if currently we have the three possible circuits, why they should have different circuits? Because we check full tuple. And full tuple here, and we have the different port number for P2 and P3. So different port number, even they have the same source IP, still you should have the different circuit at the server. Well, so this is the current discussion about multiplexing, demultiplexing. So we already have multiplexing, demultiplexing, and let you know the principle to identify the circuits. So UDP here, we have the simplified version. If we have the receiving side, so we have the IP for the receiving side. But if we want to further distinguish, we have a port number. Different port number, then we direct to the different circuit. So indeed, we consider the IP and the port number at the receiving side. That says it should be the destination. For TCP, no, we consider full tuple. And that's all. And later we will let you have the exercise. And the exercise actually shown on Padlet. You can check it later. It doesn't mean, okay, we continue to have the discussion. Take a break first, but we already have this one. You can consider to have the discussion with your member later. Okay, that's it. Before we take a rest, so can you see it? Let me make sure. I will upload the hyperlink to our line group later as well. But you can check the QR code. Can you see the current item on Padlet? It should be okay, right? If so, then that's okay. Even for students joining using online, I think that's fine. Scan the QR code first, and later I will already have the hyperlink using the line group. If no further question, take a rest first. Okay, take a rest.